Hi, today I'm going to showcase the electrohydraulic control on the EGS, the Elsworth Generating Station simulator. So first off, I will talk about what the panel is and some of its gauges. Over here, the electrohydraulic control units, the HC, is the unit that controls all the electrical and hydraulic systems for the main turbine generator and the main turbine itself. So this means all of its auxiliaries, so that will be bearing oil, hydraulic oil. In this plant's case, the generator cooling, which is hydrogen, I'm pretty sure, hydrogen cooled. We also have all of the controls for load. That will be how many megawatts does your generator, or rather, how many megawatts do you want your generator to make? The speed set point or the speed match for the turbine, as well as the cooling jack or the bypass valve, as it's commonly known, as well as pressure hold and some mechanical and electrically related trips in the turbine. In this simulator, the turbine is not finished. Only the electrohydraulic control is done, and the generator cooling simulation is done. That will mean that I am not going to delve into the turbine auxiliaries because they are currently not functional. First off, I'm going to talk about the turbine valves. So over here, you have your control for all of your turbine valves. Over here you can see all of the valves. So for example, over here you can see your main stop valve, your control valve, your combined intermediate valves, which are three intermediate valves. This is a three-stage turbine, and the bypass valve. We can observe right out of that the main stop valve is fully open and the bypass valve is almost closed. Moving on, we have the bypass valve opening jack selector. It shows currently open and closed. That means that it is ever so slightly open, but not enough to be of a concern. So we can see over here that the bypass jack in control light is not illuminated. This is because in this electrohydraulic control unit, the bypass jack is automatic. The bypass system is automatic from the start, unless you come over here to the opening jack selector and manually open the jack, the bypass valve. That will automatically disable the pressure hold system. Thus, the bypass valve and the main stop and the stop valve and the control valves wouldn't move accordingly to that, but rather you'll just be controlling the pressure of the turbine, pressure in the steam circuit, in the steam tunnels, through the bypass valve. Over here, down here, we have the condenser mechanical trips, as well as mechanical trip tests. We can see all of the condenser vacuum trips plates, mechanical trips, such as overspeed, as well as all the tests. Over down here, we have the turbine trip, the main trip, turbine trip. Over to the left, we have the pressure controller. So the pressure controller over here shows two pressure set points. So you have your pressure set point A, pressure set point B. In this current simulation, only the pressure set point A is currently functional. So you will be unable to see. Sorry, I had to check something. So you will be unable to control and change to another steam controller, another steam pressure controller, as well as the maximum combined flow limit. This switch doesn't function. Over here you also have a big trip switch. This trip switch is the unit overall trip, so this trips both the turbine and the turbine generator. Over here we have the load selector. So this is a load control, so over here you can select what load the turbine wants to aim. So for example, you can see here megawatts. It is about 90 megawatts currently. Over here you can increase or decrease the turbine, the load selection. And once you are synchronized, it will show computer in. That means that the computer, or in this case, the load matching, is functional and automatic. So you need to see it in this panel, basically holding the buttons all day. Over here we have the line speed matcher, the startup rates, the speed monitoring, and speed selector buttons. Sorry. Here we can also see the speed in revolutions per minute. So here the line speed matcher, this shows and this allows you to control the status of the turbine. So for example, selecting line speed matcher there, you can observe how the turbine instantly jumped to a really high speed. That is because the line speed matcher, what it tries to do is match the turbine to the grid. So this will try to keep the turbine as close to that 60 hertz 1800 revolutions per minute set point. Let me just quickly select it to 1800 RPM. So over here we have the speed monitor. So here it shows speed increasing or at set speed. That shows you if the speed is either increasing, moving, or decreasing, or if it's at the speed that you set it at. Over here the speed selector, self-explanatory. All valves closed, it's just stop. You have your 3 increments. You have your increments. Over here 1800 RPM is our designed limit. And we have overspeed trip test, which will overspeed the turbine to test the trip. Down here we can see the AHC status, which shows the hydraulic, which shows warning lights for malfunction on the electrical or the electrohydraulic control system itself, a lamp test for all of the lamps, as well as the hydraulic fluid pressure. So that will be it for the electrohydraulic control. We can also see over here the digital tachometer. So this shows the revolutions per minute of the turbine. Let me just quickly synchronize the turbine. Okay, so now that the turbine is synchronized, oh, yeah, I forgot that doesn't work right now at least. Well, now that the turbine is synchronized, we can observe a few things. Number one, the turbine is locked at 1800 RPM on these 2 gauges. Number 2, we can observe that the load selector, the load limit set, the computer is operating, and we can observe that the load is ever so slightly above our load set point. We can also observe that the control valve is almost fully closed. That is because we have very few reactor power. So right now we're barely at 30%, 28.8% power. Obviously we cannot increase because if the bypass valve becomes closed, that means that we are losing pressure. So we are trying to pull much more pressure from the system than what the turbine, rather what the reactor can provide. So I'm going to raise the power. Now we can observe that the reactor is almost 50% APRM, so that is about 50% thermal power. Now that we have enough steam flow, we can actually go ahead and increase the speed, the load of our turbine. So right now we are matching around 7, I saw it maxed out at 7 million pounds an hour for steam flow. But right now, because we don't have that high of a set point, it is going to bob up and down as the reactor also stabilizes out. As right now the power is very slowly increasing. I just adjusted it. So it's going to bob in and out. You can see it here. It's going to go back and forwards. It's going to slowly raise as recirculation slows down, as the pumps slowly reach that set point, which is, I believe, 46 hertz right now. So we can see we're approaching almost 50% APRM across all monitors. But over here we can also observe that our pressure is oscillating as well as our steam flow. So that is because the turbine is needing to constantly adjust for the amount of pressure changes that we have. So here we can oversee how the bypass valve is slightly more open than before, and that all of the combined valves are 50%. So we look closer, we can see that it is adjusting up and down as the pressure moves. So that is because it wants to, because, well, we have sufficient steam to increase the load. So right now I'm going to increase the load just a little bit. And after I increase it until I reach a point where the bypass valve is almost at 0%, I'm going to go and raise it to 80% power. We can observe here how I am increasing it. And as I'm increasing it, the bypass valve slowly starts closing. You can observe it, how it closes. And when it reaches the bottom, so that is 0%, that means that I'm actually going to start losing, quote unquote, losing pressure, because the turbine is trying to pull much more steam than the reactor can produce, as I said before. And slowly increase the load. Sure, you can shoot it up to the max load and forget about it, but here we are methodical. We want to take it slow. We don't want to generate too much stress on the reactor, the turbine, and the balance of the plant, because doing this actually does affect reactor powers. Again, more steam being drawn decreases and increases pressure. That creates an oscillation in power. Pressure affects power in boiling water reactors. Not a lot, but enough for it to be noticeable. What's that? Water level. I'm gonna go fix that, and I'll be right back. Alright, so after a few minutes of fiddling, we are now at 83% power. It's oscillating a little bit. Accidentally caused that myself. I don't know how to fix it, so it's just going to stay oscillating for now. Oops. Well, anyway, we can observe here the conditions are 185.5 inches. It's oscillating a bit. Earth person 171 pounds, and it's still oscillating. Steam flow is anywhere between 4 and 7-8 million pounds an hour. It's oscillating. So now we can observe over here again, the bypass valve is more open than before. So we can now proceed to doing everything. So now we will increase the load of the turbine just enough. We may be able to actually jump to the rated limit, which is 1050 megawatts. So it's more like 1044. We might just be able to reach that. So if I just keep increasing it, we can observe over here that the bypass valve is oscillating open and closed, but it's not fully closing all of a sudden. So that is good. So we want to have some steam bypassing. Not a lot, but enough. We are approaching our designated load. So that will be right there. Good. So now we can observe that the turbine is at our designated load. It's 1120 megawatts. It's slightly oscillating, but it does do that. So we are currently seeing an 83.5% APRM, slightly oscillating. Yep. And that will conclude the tutorial and the showcase on the Electrohydraulic control system over at EGS, Elsworth Generating Station. Thank you so much to the developers of this game. They've done such an amazing job. And thank you to the people that have taught me all the way through. And thank you for sticking around. I'll record more of these videos in the future, hopefully to explain the whole plant in one go. Thank you.